Hello everyone, let's solve the next question in variable acceleration motion. Read the question carefully and see what data we are given and what are the things we have to calculate. Now we are given one equation which is the relation between acceleration of the particle and the time t as it moves on a straight line path. It's a rectilinear motion question. In the earlier question, the previous question, we were given relation between displacement and time, and from that relation, from that equation of displacement and time, we reached to the equation of velocity and then further to the equation of acceleration. And for doing so, we had derived the equation. We had followed differentiation. Now we have in the beginning itself equation of acceleration. We have relation between acceleration and time, and from this equation we are supposed to reach to equations of velocity and displacement. So here we have to just follow the reverse process, and you know that the reverse process of differentiation is nothing but integration. So now here let's see how we can from acceleration go to the equations of velocity and displacement respectively. Knowing that acceleration is rate of change of velocity, let's write down it as dv by dt, which is equals to 2t minus 1. It is the given data, it is the given equation. And now let's rearrange this equation, bringing the operator dt on other side where the terms of t and the constant is there. And now let's integrate the equation. Let me show it. Let's integrate the equation, and we have integrated it both the sides, and we get v equals to 2t square upon 2 minus t plus c1, where c1 is the constant of integration. So using this information, at t equals to 0, velocity is 2 meters per second. Let's substitute it in the equation, and what we are going to end up with is the value of constant c1, and that is 2 itself. So let's substitute it in the equation that we had obtained for the velocity, so that we get a complete equation as v equals to t square minus t plus 2 meter per second. Of course that 2t square upon 2, the 2 has got cancelled from numerator and the denominator. We have simplified it. Further, now from this equation of velocity, if we have to generate equation of displacement, further we have to write v as ds by dt, and further we have to integrate it by taking the operator dt on the other side where all the terms of t are present, and that gives us the equation where again we'll have to have one unknown constant of integration c2, and to solve that we can use the given data, which is nothing but at t equals to 0, s was given 1 meter. After substituting this value, c2 comes out 1. So we have got one complete equation with all the known values of the constants c1 and c2, as s is equals to the equation number 3, which is of displacement, so the unit has to be meter. Our target is to find out what was the velocity and what was the displacement at t equals to 6 seconds. So that was our aim. So as you have guessed, we have to substitute these values, the value of t equals to 6 seconds in equation number 2 and in equation number 3, so that we are going to have the required velocity and the displacement, and those are going to be the answers of the question. Remember, if you are given equation of displacement and time, and if you have to reach to velocity and acceleration further, you need to differentiate the equation. You have to take the derivative. If acceleration and time equation is given to you and you want to go for velocity and displacement, in that case you will have to follow integration. So that is a trick you can remember all the time for solving these questions. Now at this point, let me make clear the difference between distance traveled and the position or the displacement. Remember, position and displacement both mean the same thing. and which is not equal to distance traveled. It is not necessary that always the distance traveled and the position or displacement are going to be the same. They might be same in very some specific situation, but most of the time they are not the same. So what is the basic difference between displacement and the distance traveled? Let's understand this, and let me give you one example to understand the difference between displacement and distance traveled. Let's say there is one student who is attending lectures at Abhyanta classes. So in the beginning, let's say the student is at home, and then from home he is going to come to Abhyanta classes. He is going to attend the class, and then he is going to move to the college. Let's say the student's home is, let's assume that is 5 kilometers away from Abhyanta classes, and then further from Abhyanta classes, the college which the student is going to attend further is at let's say 7 kilometers. Let's assume certain values here. There will be always a point of reference from where the motion of the particle is being monitored. So we are going to observe one point as a fixed point, or let's say origin, and from that point the position or the displacement of the particle will be decided. So let's assume that the movement of a given student from home to class and from class to the college is being monitored by Abhyanta classes, and let's say that Abhyanta classes is the point of reference. Let's call it origin. Now in the beginning, when the student has not started its motion at all, when the student is at home, let's say at H, when the student is at H, the displacement of the student or the position of the student is supposed to be minus 5 kilometers. Why minus 5? Remember, displacement or position of the particle is always measured with respect to origin. Now, if A is the origin, and from origin, if the position of the particle is on the left at 5 kilometers, the position at H becomes minus 5 kilometer. Whereas if we are assuming that the student is starting from his home for his journey to class and to college, tell me how much is the distance that he has traveled till? Of course it is 0 kilometers. He has to yet start his journey. He has to start moving. He is right now at his home, so he has not moved at all. The motion has not taken place at all, right? Let's say the student has reached at Abhyanta classes now, which is nothing but origin itself. From origin we are monitoring the position or the motion of that particle or the student. So when the student comes at A, the displacement of the student, what do we expect? What should be the displacement? Remember, displacement is always measured with respect to origin. Now if the student has already reached at origin O, position of the student from origin O becomes 0. So the displacement is 0 now. But what will be the distance traveled? The actual length of the path that is traveled by the particle is the distance. So starting from home to Abhyanta classes, the distance traveled by the student is 5 kilometers. Okay, so when particle is at origin, displacement is always 0, but now because he has started from H and has reached to A, we are assuming these are the straight line paths, so the distance is going to be 5 kilometers. Further, when student is going to move to college, displacement of the student when he reaches college is going to be how much? Yes, that will be plus 7 kilometers. Why plus? Because it is now on the positive side of origin. Remember, position is always measured from origin. It doesn't matter what is the start point of the motion, the position or the displacement is always measured from origin. Okay, so plus 7 kilometer is the displacement of the particle. Even though it has started from h, we are measuring the displacement always from origin, so it is plus 7 because it is on the positive side. But how much is the distance traveled, total distance traveled then? It will be 12 kilometers, right? So are you getting the difference between the displacement and the distance traveled by the particle? Remember, displacement is the position of the particle always measured with respect to origin, and the distance traveled is the actual length of the path that is being traveled by the particle on a straight line. Thank you.